Let's look at some properties of averages. That is how the average changes to certain changes we make to the set of observations. So starting with a set of 4 observations, their sum is 20, so their average is 5. First thing, what happens when you add an observation that's bigger than the existing average? The existing average is 5. I'm adding a 10 to the mix. Now the sum is 30 and there are 5 numbers, so the average is 6. It used to be 5, now it has become 6. So when you add an observation bigger than the average will rise. What happens if you add a number smaller than the average? So let's say I'm adding a 3 to the mix. Now the sum is 23 and there are 5 numbers, so the average is 23 by 5, which is 4.6, which is less than 5. So when you add an observation smaller than the average drops as a result. Now what happens when you add a number that's equal to the average? The average is already 5. I'm adding another 5 to the mix. Now it is a sum of 25 and that's an average of 5. Notice that the average is not changed. So when the observation added is equal to the existing average, the average does not change. That's what happens when you add observations to a set of observations. So what happens when you remove an observation from a set of observations? So we had 4 observations with a sum of 20 and an average of 5. What happens when I remove an observation greater than the average? Now I have a sum of 11 with 3 numbers, so that would be an average of 3.67. Notice that when you remove a number greater than the average drops. So with removal, the behavior is the opposite of what we saw with addition of numbers to the mix. Now if you remove a number smaller than the average, I now have 3 numbers with a sum of 18. That's an average of 6. Notice that when you remove a number smaller, the average rises. And when you remove a number that's equal to the average, you know what's going to happen? It's a sum of 15 with 3 numbers, so the average is 5. When you remove a number equal to the average holds. There's no change. The next thing that we want to look at is what happens when you add the same constant to every number. Let's say I'm adding some raising each observation by 10. So 2 becomes 12, 4 becomes 14, 15, 19. What I've done is I have increased each observation by 10. So you'll notice that the sum would become 60 and you would see that the average would become 15. So if you have a plus 10 on each observation, what happens is that you have a plus 10 on the average as well, and that's a property. You increase each observation by a certain quantity k, the average also increases by the same quantity k. Now what happens if you multiply with the same constant? So let's say I'm multiplying each observation with 10, multiplying with 10. So a 2 becomes a 20, 4 becomes 40, 5 becomes 50, 9 becomes 90. What is the sum? The sum is 200 with 4 observations, so the average is 50. Notice that when the observations are each multiplied by 10, the average also gets multiplied by 10. That's also a property that you can generalize, and you can also do this both of these steps together. Let's say I am increasing each number by 100. Let's say I'm multiplying each number by 10 and then increasing each number by 100. My observations xi are each being multiplied by 10 and then increase by 100. So 2 becomes a 20 and then becomes a 120. 4 becomes a 140, 150, 190. What happens to my average? It becomes 150 because it is also being multiplied by 10 to become 50. and then increase by 100 to become 150. So these two properties that we just discussed, you can use them together as well. It will still hold.